In the previous video, we saw that if we have x squared equals a number, then we can find the number by taking square roots. Now, it's possible that an equation might contain radical x, or the square root of x. And if that's the case, then we will need to square in order to solve. So, for example, we have radical x, or square root of x, equals 11. So squaring both sides, we get x equals 11 squared, which is 121. Furthermore, if a number is added to radical x, then we will need to subtract that number before squaring. If radical x is multiplied by a number, then we will need to divide by that number before squaring. So, for example, we have radical x plus 3 is equal to 7. We see that 3 is being added, and so we can get rid of that 3 by subtracting it. Subtracting 3 on both sides leaves us with radical x is equal to 4. And if the square root of x is 4, then x must be 16. We'll do one more example. Now we have 2 radical x is equal to 12. Here we have radical x multiplied by a number. And so to get that radical by itself, we need to divide by that factor 2. And that will leave us with radical x is equal to 6. Well, if the square root of x is equal to 6, then x must be equal to 36. Okay, here's an example where we must apply both properties. 3 times the square root of x minus 5 is equal to 16. First thing we want to do here is transfer the 5. So we add 5 to each side. This leaves us with 3 radical x on the left. 5's cancel out. And on the right hand side we have 16 plus 5 is 21. Okay, next we see that this number 3 is multiplying radical x. We want to get radical x by itself so we can square it. So the next thing we need to do is divide by 3. That gives us radical x is equal to 7. And if the square root of x is 7, then x must be 49.